Good afternoon, everyone. Our lesson today is going to be on Chapter 9.3 of Speed. The objective of today's lesson is to recall the concept of speed, which we are familiar with since our primary school time, as well as constant speeds and average speeds concept. Let us first recall the concept of speed. I hope that you find this triangle here familiar. So in this triangle, we have our distance at the top, the speed at the bottom left in particular, and lastly, we have the time. So what this triangle helps us to do is to know the formula for speed, distance, or time easily. So let's say if I want to find out the speed itself, I find that distance and time are the remaining components. So therefore, distance being at the top and time being at the bottom, hence speed is equals to distance divided by time. So a similar way to do this is that if I want to find out what is our time, okay, our remaining components will be distance and speed. So therefore, time itself will be equals to distance divided by speed. Since the distance is at the top and then speed is at the bottom of the triangle. And lastly, if I want to find out what is the distance itself, the remaining components that we have in our triangle is speed and time. Hence, distance is equals to speed times time, because speed and time are side by side at the bottom of the triangle. So this is how the triangle is being used. Let us first take a look at practice now 17, question 1. In question 1, we are given that a train travels 16.8 kilometers in 25 minutes. We want to find the speed of the train in different units. So in part I, we want our answer to be in kilometer per hour. What we have to do is that we know that speed is calculated by having distance divided by time. So we take the necessary information that we have from the question itself. Okay, but we notice that our time itself is actually given in minutes. So what we have to do is to do a conversion into hours. Okay, so minute to hour conversion will be to divide by 60. So we divide by 60 for the value of 25 only, and that is in the denominator. So now we press our 16.8 over 25 divided by 60 in the calculator, and we will be able to get 40.32 kilometers per hour. In a similar fashion, for part 2, to find the speed, we again do distance over time, but because we want our distance to be in meters and our time to be in seconds, our distance, we have to do a conversion. So we have to multiply by 1000 in the numerator. And for the time, we have to do a conversion as well into second, and we multiply by 60 to achieve minute to second conversion. Then we press into our calculator for the entire fraction over here, just as how we write it, and we will be able to get 11.2 meter per second as our answer. We next take a look at question 2 of practice now 7. In this question, we are given that the car travels at a speed of 55 km per hour, and we want to find the distance traveled by the car in 12 minutes and 30 seconds. Observe that the units of the speed is km per hour, and the unit of the time is minutes and seconds. And eventually, in our question itself, we want to find the distance, and that should be in meters. So if we were to find the distance based on doing speed times time, we cannot just take the two numbers that we see and multiply with each other. What we have to first do is to make sure that our minute and seconds is all converted into minutes. Okay, so 30 seconds is half a minute, which is 0.5 minute, hence we get 12.5 minutes. And then we need to ensure that our units for our time is in hours, so that we can multiply by the speed, which is in kilometer per hour. Hence, we need to do a conversion from minute to hour by dividing by 60 for 12.5. Now we can take 55 to multiply with 12.5 over 60, and then our answer will be in kilometer because our speed is in kilometer per hour. Then lastly, because the question wants it to be in meters, we do our conversion into meters. Hence our answer will be 11,458 and 1 over 3 meters. And this is how we approach question 2 of practice now 17. We will next move on to question 3 of practice now 17, which you may want to give it a try since it is slightly similar to question 1 which we did earlier. In this question, we are given that the speed limit of a car on the road is actually 90 kilometers per hour. What we want to do first in part I is to convert it into meter per second. So we first break down 90 kilometers per hour into 90 kilometers divided by 1 hour. So in 90 kilometers itself, we have to change it into meter because our question wants it to be meter per second. Then our 1 hour, we also have to change it into seconds because our question wants it in meter per second. Okay, then now that we have our meter and second converted correctly in our numerator and denominator, we could key in the entire thing into our calculator and arrive at 25 meters per second for our answer. In part 2, instead of using our 90 kilometers per hour and start converting from there, okay, what we can do is to convert from our 25 meters per second. So 25 meters per second can be expressed as 25 meters over 1 second. Okay, then what we will do is that our meter, we convert it into seconds. Meter we convert it into centimeters. I'm sorry about that. And then our seconds, we convert it into minutes. Likewise, keying everything into our calculator, our answer will be 150,000 cm per minute. Okay, but of course, as I mentioned earlier, instead of using 25 meters per second, you could use 90 kilometers per hour and do the conversion into cm per minute. So if you were to do that, 90 kilometers to centimeter will be to multiply by 1000 to convert into meters, and then followed by another 100 to convert into cm. As for our 1 hour, we know that 1 hour has 60 minutes, so 1 times 60 will convert it into minutes. Keying this into our calculator will allow us to get the same answer as well, so we will get 150,000 cm per minute. And this is an alternative to part 2. Let's move on to question 4. So in question 4, we are given that the sailfish, which is a type of marine animal, okay, is the fastest with the fastest recorded leap of 109 km per hour. In July 2009, the world record for the men's 100-meter freestyle was set at 46.91 seconds. We want to find out how many times faster is the sailfish than the swimmer. So in order to do the comparison, we need to first find out what is the speed of the swimmer. So we know that the swimmer swims 100 meters in 46.91 seconds. So we do the calculation by taking distance divided by time, 100 meters over 46.91 seconds. But we need to do a comparison by making sure that the units are the same. So this will give us a unit of meter per second, but our sailfish speed is actually at kilometer per hour. Hence, we do the conversion into kilometer per hour accordingly in the numerator and in the denominator, such that we recognize that the swimmer's speed is 7.6742 kilometers per hour. But this is not all. The question actually asks for how many times faster the sailfish is to the swimmer. So we need to take the speed of the sailfish to divide by the speed of the swimmer in order to figure out that the sailfish actually is 14.2 times faster than the swimmer. And this is for practice now 17. Now that we have looked at some questions covering on speed, we will move on to the next concept, which is on constant speed and average speed. So constant speed is if the speed of an object doesn't change throughout its journey. And that is almost impossible in most cases. So usually we will take a look at average speed. And average speed, we do have a formula for it, which is to take the total distance divided by total time. I want to emphasize on the word total over here because that is crucial in this formula. But before that, let us look at a certain question first. Let's take a look at practice now 18 of textbook page 66. In this question, we are given that Raju went for a triathlon and Raju swims a distance of 1.5 kilometers at an average speed of 2.5 kilometers per hour. I have illustrated this in this section in blue here. He went on to cycle 40 kilometers in 1.5 hours and runs at an average speed of 9 kilometers per hour for 1 and 1/9 hours. So the cycling part is here and the running part is over here. I have also sorted out the information that has been given such that the first row is the distance, the next row we have the speed, and the final row we have the time for each section of his triathlon. So with the formula being total distance divided by total time, we notice that we are missing the distance that he ran. So we have only the distance that he swam and the distance that he cycled. We need to find out the distance that he ran. And we can find it out since we are given the speed and the time that he ran. So the distance ran is calculated to be 10 kilometers. And that will help us to find out the total distance to be 51.5 kilometers. The next component that we need in finding out our average speed is the time component. So the time component is missing, for this part over here, for the swimming part. So we can find that out, by finding out the distance, by using the distance and the speed for swimming itself. So we will take 1.5 divided by 2.5 and we get 0.6 hours. We then add up 0.6 hours with 1.5 and 1 and 1/9 hours such that we have 3 and 19/90 hours for the total time. Although we are missing the speed of the cycling, we do not need that information at all because we want to keep to our formula and our understanding of the concept that the average should be total distance divided by total time. So we take the total distance here and the total time over here and we arrive at our answer to be 16 and 11/289 kilometers per hour, since our distance is in kilometers and our time is in hours. At this point, I want to mention why is it that we did not need to find out the speed of cycling. We cannot add the speed or take average of speed. And the reason is because the bases may be different. And the base that we're referring to in this question is the time taken for different parts of the journey. So because the time taken for the journey is different for each part, the time taken for each part of the journey is different, therefore we cannot add up the speed itself in order to figure out the average speed. Average speed will always have to rely on total distance over total time. I also want to bring to your attention about what if there is rest time. If there is a rest time, meaning to say that the person did not move at all, so he stopped and he took a rest for a certain duration, do take note that the time taken to rest is also calculated into the total time. So what this means is that if I give you an example over here, which I adjusted from your Practice Now 18, if we have a swimming distance of 1.5 kilometers for 0.6 hours, and he took a rest for 30 minutes before he continued to cycle a distance of 40 kilometers for 1.5 hours. To illustrate this, what this means is that there is a swimming portion and a cycling portion. So this takes him 1.5 km for 0.6 hours, and this takes him 40 km and 1.5 hours. But at a certain juncture here in between, we notice that there is this rest of 30 minutes, which is 0.5 hours. Okay, we can definitely see that the total distance is going to be added up to be 41.5 kilometers. But regarding the total time, we have to include the 30 minutes rest time into our calculation. You may be wondering, why is that so? The reason for this is because swimming and cycling is part of his journey, but then resting is also part of his entire journey from the start of swimming to the end of cycling. So therefore, we have to take into consideration the rest time, which is part of his entire journey. Hence, our average speed will be calculated using total distance and total time, such that answer will be 16.0 km per hour when rounded to 3 SF. And this is our approach when it comes to average speed. We now move on to Practice Now 19. So in Practice Now 19, we are given that the diameter of a wheel of a truck is 0.75 meter. So I have illustrated this in our diagram here, for one wheel. If the truck travels at an average speed of 14 meters per second, so it travels forward 14 meters per second, we want to find the number of revolutions. So revolutions means that, if I have the wheel itself, if let's say this is considered the start, whereby this point here that I've just indicated is meant to be upright, one entire revolution is if this point goes one entire round back to its beginning. So this is what it means by one revolution. We want to find how many revolutions per minute of this travel. So giving your answer correct to the nearest whole number as well. So what we need to do is to first find out what is the average speed of the truck in meters per minute. So the average speed of the truck in meter per second is given to be 14 meters per second. So when we do our conversion, all we have to do is to convert the denominator into minutes by dividing by 60, and then we will get 840 meters per minute. Why is it that we are doing this? That's because in my eventual answer, I'm trying to find the number of revolutions made per minute. So what we understand about 840 meters per minute is that the truck actually travels 840 meters in 1 minute. So let's try to imagine the journey of the truck itself. Imagine this is the wheel of the truck. If it goes in entire cycle, one entire circle, what this means is that on the floor itself, imagine this is the start point. If it continues to roll, the entire wheel will gradually touch the floor as well. So imagine that one entire cycle, if it continues to roll one round, imagine that this is actually the distance traveled by the truck for one revolution. okay, when the wheel makes one revolution. And this distance itself is none other than the circumference of the wheel. Okay, so the circumference of the wheel, with it being a circle, we recall that circumference is 2 pi r. Okay, otherwise you can also recall it as pi d, depending on what your primary school teacher has taught you. So I recall it as 2 pi r, so we need to take the diameter divided by 2, that will be the radius. Otherwise, pi d will just simply be pi times 0.75. Regardless of which formula you use, you will get 2.3561 meter for the circumference of wheel. And that is the distance traveled by the truck when it makes one revolution. So the number of revolutions per minute, okay, will be, because we see that the truck travels 840 meters in 1 minute. And one cycle itself, the circumference of the wheel is 2.3561. So what we have to do is to take 840 divided by 2.3561, and we will get 357 when we round it off. And this is the number of revolutions per minute for the truck wheel itself. Let's now take a look at practice now 20. It says that a car leaves town A for town B, which are 550 kilometers apart. So I have drawn up in the diagram here that the town A and town B being 550 kilometers apart. And the car travels at an average speed of 72 kilometers per hour. So this journey is indicated in yellow in my diagram. At the same time, a truck leaves town B for town A. So it is traveling in the opposite direction. So the truck is indicated in purple in my diagram, and it travels at an average speed of 38 kilometers per hour. We want to find the time taken for the two vehicles to meet. So when it meets, this is what I have indicated in red in my diagram. Notice that when they meet, right, the car would have traveled a certain distance, this distance here, while the truck would have traveled this distance over here. If I were to add up the distance that the car has traveled and the distance that the truck has traveled, strictly speaking, it should be equals to 550 kilometers. And that is the strategy behind my solution. Okay, so the unfortunate thing in this question is that they did not tell you what is the time taken for it to meet. But we don't have to worry. What we have to do to rectify that is to let the time taken for the two vehicles to meet be X hours. Okay, so then now that we know that it is X hours and the speed of the car is 72 kilometers per hour, speed times time will give us the distance to be 72x. Likewise, the truck will also take the same amount of time in order to do the meeting. It doesn't make sense that the truck travels in a different amount of time, because if it takes different amount of time, then they will not be meeting at all. Okay, so that's the concept of meeting. So with the speed being 38 kilometers per hour for the truck and X hours for the duration that it has traveled, the distance would be 38x, because 38 times x. And this will add up to be 550 kilometers, like I mentioned earlier. So we solve this algebraically, and we arrived that x is equals to 5. So the time taken for the two vehicles to meet will be 5 hours. So this is how we go about solving practice now 20. We will now move on to our last question for the topic of speed. In this question, it says that a car and a bus are traveling towards each other. They are 510 kilometers apart at 120 hours. Okay, 1320 hours. And they pass each other at 1620 hours. If the car is traveling at a speed of 90 kilometers per hour, we want to find the speed of the bus. So I like to be able to illustrate my questions into diagrams so that I can visualize what's happening in the question. I'm not sure whether you like the same way of approach that I'm doing. So in this case, we notice that the car, which is indicated in yellow, and the bus, which is indicated in purple, are at opposite ends of my journey of 510 kilometer. And this is at 1320 time. Okay, at 1620 hours, we notice that they pass each other. So this is what I'm trying to indicate here, that they actually meet at a certain point. Okay, this is rather unlike my other question earlier, because in the previous question, I do know the speed of the bus. Okay, so what we have to do in this question instead is that we notice that for the car to travel from this point all the way to the meeting point, the car actually took 3 hours because it is from 120 to 1620. So with that information and also the speed of the car, I can find out what is the distance of the travel by the car. Okay, so we now know that the distance traveled is 270 kilometers. Okay, so we are able to figure out what is the distance traveled by the bus. Oops, let me use a different color, which is this part here. And that will be taking 510 kilometers minus away 270 kilometers, such that I know that this is 240 kilometers. Okay, so I know that the bus has traveled 240 kilometers within the same time frame from 120 to 1620, and that is 3 hours. Therefore, I will be able to solve for the speed of the bus by taking 240 divided by 3. Don't take some time to try to understand this question. If you have any questions, you may feel free to check in with me when school reopens again or when we meet again in our next lesson. And with that, okay, we have come to the end of chapter 9.3. This is the homework for your exercise 9C. Similar to your exercise 9B homework, please submit it on Tuesday, 6 July on foolscap paper. I look forward to seeing you back in school on 6 July, and that's all for this chapter. Bye bye.